Hi, it's Angharad, the Curator at Crystal Crags here. So just to say that this talk here was presented and recorded originally in December of 2023, and we are sharing it publicly today as sort of a festive gift to you all. So if you are interested in other talks on similar themes like archaeology and paleontology, please do check out our Patreon page, and I'll put a link below to that. And it really does help support us, and we're really so grateful to our Patreon supporters that allow us to continue our online talk series that this talk was a part of. And of course, thank you so much to all of you out there for supporting Cresswell Crags.
If you sort of haven't been to one of these before, I'm Angharad and I'm the curator at Cresswell Crags. So we have these online talks roughly every other week. So I normally host them, but today I am presenting in this one. And today I'm going to be doing a vaguely Christmas related talk in that my title is Rudolph the Red-Nosed Reindeer and Other Deer in the European Ice Age. I say vaguely Christmassy because I'm just going to be talking about deer essentially. And I realised soon after starting writing this talk that I probably could have just stuck to reindeer instead of taking on many other species of deer, but here we are. So I will do my best for you. So what I normally do is I normally give a brief introduction of what the Ice Age actually is, because there are sometimes some misconceptions. So the Ice Age is used by different people to refer to different things. So I use it as sort of a synonym for what's termed the Pleistocene. So contrary to what you might think from the term Ice Age, it wasn't cold everywhere all the time. So this is a graph of temperatures. We've got the past, further towards the past on the left-hand side and the present on the right-hand side. So the Pleistocene began 2.6 million years ago and ended 11.7 thousand years ago. And the peaks in the graph are warm interglacial periods. The troughs in the graph are cold glacial periods. And then we have all these like spiky edges, which are stadials and interstadials. So slightly cooler and slightly warmer periods. So I'm going to actually be using the term Pleistocene from now on. The reason I use the term Ice Age in the title is just that it's a lot more of a common word than the term Ice Age. I know lots of people have heard of the Pleistocene, but some people may not have done. And it's just, I didn't want people to be put off if they'd not heard the word Pleistocene and didn't know what I was talking about. Okay, so deer in Pleistocene Europe then. So essentially what I'm going to be doing in this talk, I'm going to be introducing some of the key deer species that lived in Europe during the Pleistocene. Then I will be talking about what else we can learn about those species. I'm going to be talking about their interactions with other mammals, including humans as well. So I'll start off by our main deer species, the reason that I'm giving this talk, so the reindeer. So today, reindeer are present in northern areas, including Canada, the USA, although mostly Alaska, Norway, Finland, Russia, and Mongolia. So reindeer was present in Britain during quite a few periods, especially in the late Pleistocene, mainly the colder periods, although some slightly warmish periods as well. And if we think about Iberia, today it's fairly warm, being towards the south west of Europe. In the Pleistocene, it didn't have as such cold conditions as further north, although there were periods, these stadial conditions, that were cooler than sort of the rest of the middle of the last glacial period. So in Iberia, there's been lots of studies about the presence of cold tolerant species in Spain and Portugal. When reindeer were present in Iberia, these tended to be sort of cold and also dry periods. So there's a period called the Younger Dryas just before the end of the Pleistocene. And while that was cold, it was also quite humid, and that seems to have been unsuitable for reindeer at the time. And they were also associated with steppe grassland environments. Other cold adapted species, such as the woolly mammoth and woolly rhinoceros, were also seen in Iberia as well. The reindeer was actually the last cold adapted mammal in Iberia, with its last appearance just into the Holocene, which is the warm period we're in today, so just after the end of the Pleistocene. And there's also been research into where reindeer were found in Iberia. So they were found in two main areas, sort of either end of the Pyrenees, and further inside of Iberia, where they were found, they tend to have been modified by humans. So it's thought that away from these areas, either side of the Pyrenees, the humans actually brought some bones or antlers of the reindeer further into Iberia. And while the reindeer were found in those areas, other cold adapted species like the woolly mammoth and the woolly rhinoceros actually managed to occupy more of Iberia during these cold periods. Okay, so a bit about sort of how reindeer are so well adapted to the cold. So it's able to live in the places that I've outlined, including Lapland with Santa. So physically, the reindeer has hemoglobin properties that allow for oxygen delivery to limbs and distal appendages, and that also helps to reduce heat loss. They have broad hooves and prominent dew claws, and they might be ideal for digging through snow to reach vegetation to eat. So we've got a nice snowy picture of a reindeer there. They've got short, hollow guard hairs, and they also have fine underwool as well in their coat. And this helps them to stay warm, and they are also able to alter the degree of insulation of their fur through piloerection, which is like the bristling of hairs. So I'm assuming that's sort of similar to what happens to us when we have like goosebumps and the hairs on our arms stand up. And their long, furry legs are ideal for moving through snow. So just before I move into the next slide, I should have mentioned this image on the left-hand side. So that's a reindeer mandible from Pinhole in Creswell Crags. That's part of our collection. And this was dated to roughly around about, I think, probably 55 to 45,000 years ago. So in the middle of the last glacial period, sort of a cool, dry period, ideal for the presence of reindeer. But what about their red nose? So did reindeer have red noses in the Pleistocene? Well, even though it's probably very unlikely that the reindeer ever had a nose that glowed bright enough to guide Santa or anyone else for that matter through dark nights, some reindeer actually do today have visibly red noses. And this was studied only quite recently. And they found that the redness of the nose is because of a dense area of blood vessels, and that allows for temperature regulation when the reindeer become overheated. So it allows them to sort of lose heat in their sort of nose area when they're doing strenuous tasks that lead them to become quite hot. The second deer species I'm going to be talking about is the red deer. So red deer are present across much of Europe and also a tiny bit of Western Asia and Northern Africa as well. And its furthest north location is in Norway. So the red deer was found in Britain during both cold and warm periods in the late Pleistocene. However, we have no evidence that it actually reached Creswell Crags. So for those of you who may not know, so Creswell Crags is on the Nottinghamshire-Derbyshire border, which is in the Midlands area of England. It's in the middle of England. So while it was found in southern England, it wasn't found in Creswell Crags nor in the surrounding sites as well. So this might be because sort of the southern area of Britain was towards the north of its range, and it might have been that areas further north were just not suitable enough for them to inhabit. And I will also briefly talk about the fact that there existed dwarf red deers during the Pleistocene. And one example is the dwarf red deer on the island of Jersey. So because of the sea level rise during the last interglacial around about 125,000 years ago, the red deer became isolated on the island of Jersey. So before that point, the red deer were able to reach the island because of the lowered sea level. And after becoming isolated on the island, the red deer reduced in body size. So the mainland male red deer weighed roughly around about 200 kilograms, whereas the tiny deer on the island of Jersey weighed roughly only about 36 kilograms. And that's a reduction of around about 164 kilograms. And that occurred over only 6,000 years, so not very long at all. And it's thought that this is to do with one or two factors. And this is very common in species restricted to islands. So large animals like herbivores tend to be reduce in size when they're isolated on islands. So this might be because of the absence of predators. So a large body size is needed to defend against predators. If there's no predators, they don't need that large body size. And another reason might be because the island might not have had enough resources to support the large body size of the red deer either. And dwarf red deers have occurred in other islands as well during the Pleistocene, such as the Mediterranean islands like Crete. The next species is the roe deer, Capreolus capreolus. And today the roe deer is present across much of Europe and a little bit of Western Asia. And the northern limit of its distribution is actually a slightly higher latitude than that of the red deer. It wasn't found very often in Britain, at least not in the late Pleistocene, only during two slightly not full interglacial, not full warm conditions, but not during the cold glacial conditions, so kind of warmish conditions. And then if we're looking at roe deer in the rest of Europe during the Pleistocene, during the middle of the last glacial period, which was a time roughly in around about 58 to 25-ish thousand years ago, the roe deer were able to reach Central Europe, just north of the Alps. And during the middle of the last glacial period, there was fluctuations between the cool stadials and the warmer interstadials. And it's thought that the roe deer might have reached these more northern areas in Central Europe during the warmer interstadials. During the last glacial maximum, which was a cold period, roe deer were present in southern Europe, including Iberia, Italy, and Greece, southwestern France, and around the Carpathian Mountains. And then after the last glacial maximum, when the temperatures started to warm again, they then moved further north. And then we've got the fallow deer. So today, the fallow deer is present across much of Europe. Most of its range is a result of being introduced by humans in historical times. The fallow deer was found in Britain during, as far as I could tell, mostly interglacial periods. After the climate began to cool, fallow deer retreated to southern Italy and Sicily as well, and the southern Balkan Peninsula. And interestingly, during one of the interglacials that it was present around about 400,000 years ago, there was a large version of fallow deer present in Britain. The elk was also present in Europe. Today, it's found in the USA, again, mostly Alaska, Canada, and North and Northwest Europe, and also Northern Asia. Elk was found in Britain, not very often, and it is quite an uncommon find, as far as I could tell, in European deposits from the Pleistocene than other deer species. So actually, I'm not going to be talking about elk very much. I think I've got one more mention of it briefly later on, and that's it. And then this is one you might have heard of, quite a famous species, Megaloceros giganteus, the giant deer, sometimes called the Irish elk, but it's not actually an elk, and it wasn't only restricted to Ireland. And this is the sort of the mounted skeleton here of a giant deer. So it's now extinct. During the Pleistocene, it ranged across Eurasia. In Europe, it occurred between around 43 and 58 degrees latitude north. And it's probably best known for its massive size. So you can see its massive antlers here. So they could have an antler span up to around about 3.6 meters. And these antlers were shed annually. And then they had to grow this massive antlers every single year, which is quite incredible. It was present in Britain during warm and cool periods. It was also found in Iberia. And while it was found associated with the cold adapted species, it's actually thought that the reason it was found in Iberia during these times is that when there were colder periods, the sea level was lower, and the giant deer was able to migrate into Iberia around the edges of the Pyrenees, which they wouldn't have been able to do when the sea level was higher. There was a potential absence from Europe for around about 10,000 years, which partly coincided with the last glacial maximum. So as I mentioned, this was a severe cold period. And alongside the cold conditions, there was reduced vegetation productivity at the time. And that might have resulted in vast areas of Europe unable to support this big giant deer. After the last glacial maximum, the giant deer shifted and expanded its range out of whatever refuge it had been living in and inhabited areas of Europe again. However, it seemed not to inhabit the southern areas in which it was found before the last glacial maximum. And this is thought because while the temperatures were warming, the vegetation might not have been suitable because in these more southern areas there was a denser tree cover, whereas the vegetation elsewhere was more suitable, and that has been described as a forest tundra steppe sort of mixed vegetation environment. And the giant deer finally disappeared from Europe during the Younger Dryas, which is the cold period just before the end of the Pleistocene. And the vegetation at this time was replaced by a vegetation of lower productivity, unable to support these large species. As some authors have suggested that in the case of the giant deer in Ireland, for example, there may have been opposing forces in place. So there are predators such as wolves, and as I mentioned earlier, a larger body size is advantageous in predator avoidance. However, the larger body size necessitates enough food to sustain it. And with this lower productivity vegetation, there just might not have been enough food around for the giant deer to survive through the Younger Dryas. And there were many, many other species, most of them extinct, present in the Pleistocene of Europe, but that is beyond the scope of my talk. I think the ones I've outlined so far are enough. And this is just some giant deer teeth from Techoneras in Spain. So they are quite massive. It's hard to tell because you've got a scale down there, it's 3 centimeters. But if you're able to find some giant deer teeth in a museum, for example, and compare them to the size of other species such as reindeer, you can see how much bigger they actually are. Okay, so I'm going to be talking a bit more about what we can learn about the behaviours of these deer species. So one thing I'm going to be talking about is seasonal migrations. And we can understand past migrations of herbivores through looking at strontium isotope ratios extracted from their teeth. So the geology of an area has specific strontium ratios. This influences the strontium found in soil and water in the area, and this then influences the strontium found in the vegetation. The strontium then becomes incorporated into the enamel of the herbivores as the teeth are growing as a result of the vegetation that they've eaten. So researchers create a map of strontium ratios in the area of study, and they compare these values to the strontium values from the dental enamel. So what they can do is they can sample strontium from the enamel through the tooth. And as the strontium becomes incorporated into the teeth as the teeth are growing, changes in the strontium can be seen through the tooth, potentially, and this may therefore indicate migration of the individual while the teeth were growing. And what they tend to do is sample from a number of different molars, because those molars grow and erupt at different points in the individual's life. So the first study I'm going to be talking about is reindeer migration, and this was a study published this year by Cape Breton and others, and this looked at reindeer migration of reindeers found in Abry du Maras in France. And they found reindeer from 2 different levels. So there was level 4.1, where the reindeer was dated to around about 46 to 40,000 years ago, and level 4.2, which was dated around about 55 to 42,000 years ago. So very similar ages with overlapping ranges. However, the reindeers from the 2 levels differed in the strontium ratios and thus their migration patterns. So the graph here shows the strontium ratios. The reindeer from level 1 are in green, red, and orange, and they show very similar strontium ratios across the graph, and therefore strontium ratios through the life when the teeth were developing. And this meant that these reindeer actually didn't migrate far from Abry du Maras. However, the reindeer found in level 4.2, shown in blue, shows very different values towards the left-hand side and the middle of the graph, and then very similar values towards the right-hand side of the graph. And this indicated that the reindeer inhabited an area roughly around about 150 to 200,000 kilometers. No, I'll say that again, 150 to 200 kilometers, not 1,000 kilometers, kilometers away from Abri du Moras during the winter before migrating to the area around Abri du Moras during the summer. And now we've got red deer migration. So this was a study also published this year by Barakat and others. And this was looking at Lazaret Cave in France. And this was a period from marine oxygen isotope stage 6. That was a glacial period, I think roughly 200-ish thousand years ago. So they looked at strontium and oxygen isotope ratios from the red deer teeth. And from the ratios that they found, it looked like all the individuals were likely born in a similar location. But the summer and winter ranges were different. So this map here shows the areas that the red deer inhabited during different parts of the year. So at the bottom, we've got winter. And the star here in the middle is Lazaret Cave. So the blue areas are the strontium isotope ratios that match those found in the teeth for winter. And in the winter, they only sort of lived potentially as within 5 kilometers of the caves, and that was also in lowland areas. However, in the summer, this is shown with the sort of orangey, red, yellow colors on the map. They migrated further away from Lazaret Cave, around about 20 to 30 kilometers away. And these were more highland or upland areas. And actually this migration from lowland areas in the winter to upland areas in the summer is found in some red deer populations today. Okay, so the next thing I want to talk about is paleo diet. So past diets of deer species. How can we reconstruct their past diets? So there are a variety of methods we could use. So we could look at the mesowear, so looking at sort of the broad wear of the teeth. We could also look at microwear. And microwear is microscopic wear of the teeth. So looking at pits and scratches on the enamel of the teeth. And these are sort of show the diet of the last few weeks, I believe, of an individual's life. We can also look at carbon and nitrogen isotopes, and we can also look at vegetation trapped within the teeth. So that's not super common, but it does occasionally happen. And I'm going to be talking about a couple of examples about that as well. So this study looks at reindeer diet, again, published by Kate Britton and others just this year. So this was focused on Les Lecottes in France. I apologize for the pronunciation. And they looked at carbon isotopes from the reindeer. So you can see we've got the reindeer in blue, we've got bison in red, and we've got equus or horse in green. And you can see during sort of level 2 that the carbon isotope ratio of red deer and bison were fairly similar, but then the carbon increases much more in later levels or the earlier levels, sorry, than the other species. And the authors interpreted that this higher carbon isotope ratio was due to the reindeers consuming lichen. And this occurs in reindeer today. Reindeer have often been documented consuming lichen. This was potentially due to a greater abundance or availability of lichen in the area, or it could have been due to competition from other species leading to reindeer consuming a food source that other species could not exploit, or a combination of the two factors. And then we're looking at giant deer diet now. So we've got a few studies here. So dental microwear and dental mesowear of middle to late Pleistocene giant deer populations were studied, and this indicated quite a wide variety of dietary behaviour, including grazing, leaf browsing, and also mixed feeding, but there was a general tendency towards mixed feeding and grazing. There was a study published by Van Giel and others in 2018, and this looked at a giant deer molar that was found in the North Sea. And the tooth contained masticated plant remains. Quite remarkable that, sorry, my computer's had a pop-up. Quite remarkable that not only has the tooth preserved, but the plants have also been preserved within the tooth as well. The tooth was dated around about 43 to 42,000 years ago, so this sort of cool, dry, middle of the last glacial period. The majority of the plant remains were identified to sage, so Artemisia, with a smaller percentage of Asteraceae. So the authors suggested that Artemisia contains quite a high calcium content, and this might have been consumed out of necessity by the red deer, potentially by the males in order to obtain enough calcium to grow their antlers, these big massive antlers that we saw earlier, or potentially by the females in order to obtain enough calcium needed while they were lactating. And then another study published by Van der Kamp just this year looked at a maxilla of a giant deer found in the Netherlands. So that's this maxilla here. And they also found vegetation within the folds of the teeth. So this middle image here, I think it's this this area in the middle here where my mouse is. I think that's the vegetation, because then in the image on the right hand side, this is after sampling where the vegetation has gone. The vegetation was sampled for pollen, and given the characteristics of the pollen, it was inferred that the vegetation entered the tooth folds through mastication rather than through sediments or modern contamination. Although some of the pollen, especially those with low percentages, were thought to have been wind-blown pollen or potentially insect dispersed pollen, as this pollen might have landed on another plant and became incorporated into the tooth folds when that particular plant was eaten. They consumed quite a variety of plants based on the pollen that was found within the teeth. So this included cow parsley, cow parsnip, water pennyworts, species within the daisy family, Filipendula, grasses, and comfrey as well. And this was different to the diet of other giant deer individuals that they looked at. And this might have been due to the different behaviours of this particular individual, or might have been due to the local availability of plants, whether that may have been seasonal availability or just the fact that those plants generally grew in the area that the giant deer was living in. So I've spoken about what we can learn about the deer themselves, but on a slightly less happy topic, I think, at least for the deer, I'm now going to be talking about what we can learn about what was eating the deer, in particular mammalian carnivores. So there are a number of ways that we can look at past diets of carnivores. This is, for example, through the accumulation of bones in dens, such as hyena dens, through damage to bones, such as gnaw marks or digestive marks, and also through isotopic analysis, specifically measuring the carbon and the nitrogen isotopes from the carnivores and herbivores in order to reconstruct a food web. So if you've been to my talks before, you've probably heard me talk about hyenas, and I very rarely go through a talk without mentioning hyenas. So I apologise if you're sick of it, but I like them. So we've got some lovely illustrations of a Pleistocene spotted hyena from Europe on the right-hand side there. I believe it was a stamp from Moldova, I think. So deer remains are quite common in spotted hyena dens across Europe. So spotted hyenas are really well suited to consuming bones. So many bones in hyena dens exhibit characteristic gnaw marks and sometimes evidence of digestion. Although when there's a bone that has digestion, it's mostly a fragment. So in order to determine what species that is, we can do what's called zooms, or zoology by mass spectrometry, or collagen fingerprinting, and that's looking at the the collagen fingerprint of a particular bone, matching it with the collagen fingerprint of known species, and that will tend to give us a match to species or genus level, and that will tell us what animal the digested bone belonged to. So many species of deer have been found in hyena dens in Europe, including reindeer, red deer, giant deer, roe deer, and fallow deer. And specific examples that I'll just quickly go through included Castle Poot Cave in Ireland, which had gnawed reindeer bones. There was reindeer, red deer, and giant deer from Kent's Cavern in southern Britain. Finumbino in Britain had reindeer and red deer. Sicilian red deer were found in San Teodoro on Sicily, and generally in late Pleistocene Italy, based on the faunal remains, the red deer was determined to have been a very important species in the diet of spotted hyenas. There's also isotopic evidence of spotted hyena consumption of deer. So at Saint-Césaire in France, reindeer were consumed by hyenas. They consumed roe deer and giant deer, and paillard in France, I apologise for the pronunciation, and also in France, in Jonzac, giant deer were consumed by hyena. And then in addition, another method that I forgot to mention was looking at ancient DNA that can be extracted from coprolites. So coprolites are fossilized poo. Because hyena they've got sort of the masticatory muscles and the sort of the morphology of the jaws and the teeth in order to crack and chew bones. Their digestive system is also really good at digesting all but the inorganic portion of bones. What remains is the calcium phosphate content. This comes out the other end in the hyena's feces and helps it to preserve for thousands of years as a coprolite. And some researchers, Bonnettel, extracted ancient DNA from a coprolite from Cumir in France. And as well as spotted hyena DNA, they also found DNA of red deer, indicating that this individual had consumed and digested the remains of red deer. And then in terms of other species predation upon deer, there was some isotopic evidence done on a site in Germany that I will not attempt to pronounce because I will definitely get it wrong. This indicated that wolf preyed upon red deer and giant deer, and the cave lion were consuming reindeer. And predation of lion upon reindeer was also observed elsewhere in Germany in the Swabian Jura. So the last part of my talk, I'm going to be looking at the use of deer by humans. So first of all, if we stick with the topic of diet, we can look at what humans were eating by looking at the marks that they made on bones, such as cut marks or percussion marks, and we can also look at the carbon and the nitrogen isotopes as well in the humans. So there was a study looking at La Viña in Spain, and they looked at 2 Gravettian levels, so levels where remains were accumulated by modern humans, dated around about 34 to 28,000 years ago. And the most common species found in these levels was the red deer. So bones of red deer, in addition to other species like the chamois, the horse, aurochs or bison, exhibited human modification. So these included cut marks, impact marks, and alterations by fire. Although in the latter case, most of the remains damaged by fire could not be identified to species. The marks were indicative of activities such as dismembering, disarticulation, and skinning of carcasses, and also utilization of bone marrow. And while the degree of marking on bones was similar in both levels 10 and level 9 in the cave, level 9, which was slightly younger, had a greater number of modified small bones, such as the carpals and the tarsals and the phalanges, so the wrist and the ankle bones and the finger bones, and also on the ribs. And this indicated a greater usage of carcass from level 9. So this is a really lovely figure. So I'm just going to briefly talk you through what we can see here in this figure. So we've got specimen A, and this is a metapodial. So a hand or foot bone of a red deer, and this has a fresh fracture mark and butchery marks, but its bone surface is also altered by what's called root etching. And I love looking at root etching. It looks really pretty, and essentially it's the acid from the roots of vegetation, of plants, etching onto the surface of bone. B is a mandible fragment of a juvenile red deer. C is a humerus shaft of an adult red deer with cut marks and fresh fractures. So I think that slightly zoomed in bit on the right hand side is the cut mark. D is the radial shaft of a red deer with cut marks and highly altered by root etching again. So you can see this close-up image where my mouse is, that has root etching. And then just to explain what the other animals are, E is a fragment of an aurochs or a bison of a humerus with cut marks. F is a rib fragment of horse with cut marks. G is a digested phalanx of an ungulate, indeterminate species. H is a fragment of a phalanx, another finger bone of a cave bear. And I is another finger bone of a leopard. So other studies have looked at reindeer in the Iberian Peninsula. So from a site called Texa in north of Spain, reindeer remains had cut marks and scraping marks indicative of being worked by humans. And another site, Axlor, towards the north of Spain, also yielded reindeer remains worked by humans. And there was another site as well. But again, as I mentioned, there were also sites towards more central Iberia, but they were mostly likely have been brought to the area by humans rather than the reindeers living in that exact area themselves. There were 2 sites in Italy that were looked at, and those sites exhibited had bones that exhibited damage and modifications by Neanderthals. So one site was Riparo del Broion. I'm so sorry about my pronunciation of all of these sites. This site had giant deer, a species that might have been elk or giant deer, roe deer, and an indeterminate deer. And these exhibited cut marks, percussion marks, and burn marks. There was a San Sebastiano cave, and that had red deer, roe deer, and indeterminate deer, and had similar modifications to those found in the other cave. In the Del Broion cave, the freshly fractured bones, percussion marks, and cut marks indicated that meat and marrow exploitation had taken place by the Neanderthals. This was in the case of the red deer and also other ungulates too. In the San Sebastiano cave, most of the human modifications were on red deer, roe deer, and the indeterminate cervids, and the author suggested that this might have been selective hunting strategy of deer rather than the other species. And indeed, in the late Pleistocene of Italy, red deer was determined to be one of the most important prey species for humans. And then thinking about the isotopes, isotopes were looked at in southwestern France, and in terms of Neanderthals, they were consuming giant deer among other species. And from Spee Cave in Belgium, the Neanderthals relied upon reindeer and other species based on the isotopes. Okay, so humans also used the bones and the antlers of deer to construct tools. So this is a study published by Blasco and others in 2013, looking at Bolomar Cave from Spain, and they found a shaft fragment of the right femur of a red deer, and the breakage morphology, sort of V-shaped outlines, the angles and the smooth edges indicated that the bone was fresh when it had been fractured. And the colour of both the fractures and the rest of the surface of the bone was very similar, indicating that the breakage had occurred prior to excavation and not as a result of it. There was also an area of oblique, short and steep striations on an area of the bone. And the morphology of the striations are different to the morphology of cut marks, but the morphology of the striations was similar to damage that occurs when a bone is used for retouching a stone tool. So essentially retouching is using a bone or an antler to modify the shape of a stone tool. And there's been lots of experimental archaeology looking at what occurs to a bone or an antler as a result of these retouching activities. And then looking at France in Le Ronde du Barry, there was Magdalenian deposits around about 14,800 to 14,200 years old. And there were 60 antler artifacts. 55 of those were from reindeer and others from an unidentified cervid. And most of them were shed antlers. So the antlers that the reindeer and other deer had naturally dropped when they were alive. There were many spear points constructed from the antlers. Some of those had barbs on them, and one had striations indicating that it had been hafted to a shaft, such as one made of wood and used as the tip of the spear. There was also one long tool which was beveled and created through scraping and abrasion. And the entire surface of the antler had been worked by scraping. There were traces of wear which indicated that it had been used as a retoucher. And there was also some tools that were beveled, and some had evidence of scraping on the surface as well, aside from this one. And there was also a perforated baton. So this is sort of part of an antler which had a hole in one end, and it had been engraved with what was apparently a female figure, potentially. And I do wish I could have included an image in this PowerPoint here for you, but unfortunately I couldn't find a copyright free or open access image. So if you notice that there were a few areas where I could have included images in this talk, it's not for want of trying, it's just that sometimes images are hidden behind a paywall, or they're copyrighted, or they cannot be used for commercial purposes. And then finally, deer feature in the art and ornamentation of humans. So I can't talk about deer without talking about the red deer art found in Church Hole at Creswell Crags. So this was only discovered, the rock art, at Creswell Crags was only discovered 20 years ago in 2003. So we've been celebrating our 20th anniversary this year. That was discovered by Paul Barn, Paul Petty and Sergio Ripoll. And the red deer on this panel, I'm going to outline it with my mouse for you. So we've got sort of its ear here, its antler here, and then going down its antler. Got the front of its face. We got its neck, its leg here, its belly, and its leg there as well. And the rock art at Creswell Crags has been dated to more than 12,600 years old. And this is based on the uranium content of flowstone. So flowstone is this white stuff that you can see here where my mouse is towards the right of the image. And flowstone is essentially calcium carbonate, the same substance that stalactites and stalagmites have been made out of. Where this overlies the rock art, such as these notches at the bottom of the red deer, this gives a sort of a minimum age for the rock art. So we know that where the flowstone is dated to around about 12,800 years old, 12,600 years old, the rock art is older than that. And there's also been other representations of deer in the late Pleistocene of Europe, such as Lascaux in France. This may be a giant deer. Lascaux had hundreds of paintings, included deer species from the Upper Paleolithic. There's also giant deer featured in Cognac Cave, also in France. And rock art in the Iberian Peninsula also has reindeer, but the presence of reindeer in rock art is much more prominent in France on the other side of the Pyrenees. And then we've got portable art as well. And I can't not mention this beautiful image, which is called the Swimming Reindeer from France, made out of mammoth ivory, I believe roughly around about 13,000 years old. And it's been interpreted as a male and a female reindeer swimming together, and they both have their antlers. And then almost finally, we've got ornamentation as well. So you find the remains of animals, particularly their teeth, used as ornamentation found in late Pleistocene sites in Europe. So this study, published by Tegero and others in 2021, looked at perforated teeth found in 2 sites in Georgia. One site was dated around about 39 to 43,000 years ago, and the other site was dated around about 25.5 to 24.4 thousand years ago. There were mostly teeth found, but there were some bone pendants as well. The majority of the teeth were of red deer, but there was also goat and bison or aurochs present as well. They looked at the shape of the holes in the teeth, the wear marks, also the breakage and the ochre stains of the teeth. So there were marks on the teeth that indicated that they were removed from a jaw of a relatively fresh carcass rather than from a skeleton found in the landscape. There was evidence of scraping and polishing prior to perforation. So there's ochre combined with water that may have been used to polish the tooth. The tooth was mostly perforated around the root. And there was evidence of polish around the edges of some of the holes, indicating that the teeth had been suspended, potentially used as jewelry or to decorate clothing, maybe of being sewn into clothing. And then finally, I can't talk about human interactions with deer without asking, did reindeer in the Pleistocene pull Santa's sleigh? I doubt it. I highly doubt reindeer were able to sort of float as they do in that image. And indeed, they were not, unfortunately, domesticated until after the Pleistocene. But I will leave that to your imagination as whether you believe that reindeer in the past could fly. So that is me. So thank you very much for listening. I'm going to stop sharing now. Okay, so first question, did giant deer live in the UK? They did live in the UK. They were present, I'll just grab my notes. Present a few periods, quite a few periods. So they were present during the last interglacial around about 125,000 years ago. Then they were present in the subsequent glacial period as well. So they're present quite a few times in the UK, and also, of course, in Ireland, not too far away as well. Did the hyenas scavenge remains after other predators had eaten the meat first? That is a really good question. It's actually really, really hard to tell because hyenas have this tendency to gnaw bones. If there was damage caused by other predators to the bone, including cut marks by humans, very often the hyenas probably would have overprinted that evidence. But I mean, spotted hyenas today, they do scavenge, but they're also very, very proficient hunters as well. So it's probably likely that in the Pleistocene, the hyenas could both scavenge and hunt their prey as well, depending on availability. So today, the hyenas will scavenge if that's the most easy and nutritious food available to them, or they'll hunt if necessary as well. And I think as that's all the questions, I would like to wish you all a Merry Christmas if you celebrate it. I would like to, if not, happy holidays. Have a lovely end to your year. I've really appreciated all of you. So whether this is your first talk or whether this is like your 20th talk that you've been to with us, I really, really appreciate all your support. And thank you for the lovely comments in the chat box as well. I do appreciate it. I've really enjoyed hosting these talks. I've enjoyed giving these talks. You're all fabulous. Thank you so much for supporting Creswell Crags. Have a lovely rest of your year, and I hope to see you at some of our talks in the future. So bye-bye, everybody.